Okay, we can continue now with a little bit different subject. This work we are doing about 10 years in a slow pace with Professor Leventis of the University, Northeastern University in Boston, and myself. And I think it's an interesting area, and we have some good results. A lot of people have been involved, mostly master students, and I'll present that later. Why I cannot move? I cannot move.
Click there and you should go to.
Click. Okay, and no, okay. You know, all of you, that fire is a big reason cause of loss of property alive. And although, as you have heard, there are several techniques, there are several cases, especially when you have hazardous materials in industrial plants, that current techniques may not be adequate. And the chemical and fuel fires pose more dangerous situations for firefighters. So currently, for this case, the firefighters use a combination of foam and water in order for these fires to prevent them from spreading. However, both have limited effectiveness, and we decided about 10 years ago to examine whether liquid nitrogen can be used for this purpose. It's not the first attempt. Professor Rasbas here did also some experiments using liquid nitrogen for extinction. The method may be suitable, as I said, I saw near the end of my talk, for big tank fires, like the Bunsfield fire we saw here, which generate a lot of flames and smoke. And there are two pictures there. And what are the characteristics of extinction of the fire with liquid nitrogen? Liquid nitrogen, which is 75 Kelvin, vaporizes, of course, very quickly, and it generally is environmentally benign, except if it's in a closed room, which are other considerations, and does not cause additional property damage or contamination of the groundwater, which is a problem with foam. Now, what happens when the nitrogen vaporizes at this temperature? It displaces oxygen, and as I said, it would not be acceptable in most cases for enclosures where people are living, are staying. The direct application on the surface causes two things: vaporization and sudden expansion of volume. This creates a layer that covers the surface of the liquid pool fire and prevents the oxygen to interact with, mix with the fuel. So the combustion of the fire goes out. For example, if you do some calculations of applying liquid nitrogen on about 77 Kelvin on a horizontal surface, in addition to cooling, you have an expansion about 175 times of the initial volume. Also, additionally, the nitrogen expands more as the temperatures increase. And So the expansion can reach about 645 times. And even in higher temperature, we have additional expansion. This will cause smothering of the fire. And this occurs very quickly. This observation and the experience we have had with a lot of experiments, which I will describe very briefly next, is that the best way to apply the nitrogens directly on the surface, for the reasons I described very briefly. Very little has been reported of applying liquid nitrogen, and one reason you will see we did some experiments with fiber gauge. So this is the first systematic work that has been done to apply this liquid nitrogen for extinction of pool fires. The effectiveness of liquid nitrogen was demonstrated in experiments with Professor Levendis and I did in Northeastern University. So this was a very small pool fire, 20 centimeters. But we use very small quantity of liquid nitrogen, 2 to 3 milliliters. And the extinction of the fire was very, very instantaneously. Here we saw some pictures of the pool fire, the application of liquid nitrogen, and also on the insert there is a temperature at 5 locations along the axis of the pool fire, which shows how quickly it went out. When I was in Australia, director of the fire lab there, we did experiments in a bigger pool fires using diesel oil or propanol. This was 1 square meter. With 2.5 centimeter deep liquid fire. And we put it in a bigger diameter pool with water. The diesel was ignited with a small help of gasoline, and the fire went on for a few minutes. The nitrogen was about 1 liter or less. It was poured gently from a small height, 15 centimeters above the fire, in 3 locations. At one corner of the pool fire, inside the pump, in the pool of water, outside the pump. There was a water pump outside the liquid nitrogen pump. Either or at its 2 corners or along the front side between the 2 pumps, and along the floor outside the pool pump. Now, even if you put the liquid nitrogen on the floor here, you put it, there is a flow, like a gravity wave, generated for a significant distance. And this can be untrained by the pool fire and extinguish the fire. That's what we examined there. So the most important thing is that when the liquid nitrogen was applied at the center of pond fire, the extinction was very quick. And a cloud of nitrogen, after you apply, spread along, across, and covered the pool fire. And this was shown that even if it was wind, because of ventilation in the room, this technique applied very well. The other applications were not as successful, except if there was a favorable wind. So this is some pictures of this experiment. with the pool file growing, and then we apply the liquid nitrogen, and you can see how the liquid nitrogen covered all the whole area. So this was one series of experiments. Then we did some experiments in the fire department of Boston, where we use again 1 square meter fire. And we use 1 liter again of liquid nitrogen. The purpose was to demonstrate or to fight against that this can work. In another case, we applied 1.5 liters. And in both cases, fire was extinguished. And here is the pictures of the fire and the application with a bucket by the firefighters. So this demonstrates that it could put out liquid pool fires. And we did also some experiments some time ago, factory neutral, extinguishing wood creeps. So we have demonstrated the applicability of the method. The question is how to deliver it. And this is the critical issue. How to deliver liquid nitrogen in the center of the pool fire. So here it demonstrates how firefighters can put foam on during the bushfield depot fire. And starting from that, we have, as I said, that although this took 10 years, we didn't have substantial funding, but funding from here and there. So, first of all, we have to take the track, and hose, and the nozzle. And there was a lot of work that was done. I would say that liquid nitrogen, it's easy to produce. It is very inexpensive. So the cost is not a big problem. And one big problem is its delivery. And the track is okay. The pump and the nose and the tube are fine. And then we have to design a nozzle that can keep the liquid nitrogen in liquid state and let it and then inject it. And now we thought that this would be a good way to be used by the firefighters to inject it into the pool fire. But you will see that the issue is that the liquid nitrogen vaporizes very quickly. And this is the distances that liquid nitrogen will travel before vaporizing. The projected distance is on the top, and the pressure and the size of the nozzle is given by these curves. Okay, so it's not easy to apply the liquid nitrogen using the nozzle, and so we thought that we can use a robot. And we did some experiments. This is it's a lot of work by master students. All these things, imagine, is the master thesis, okay? Systematically, how, not randomly. And this was the application using the sketch of the robot. And this, of course, we did. We did. The student constructed it and applied it, and it worked, okay? So, I mean, I would say that there are so many people that have been involved in this work, and we will still continue it. I would like to say that this work, similar work done by Professor Rasbas some years ago, and this is one of the reports, BRE report. Okay. I would like to say the scientific part that we have not done yet, but we've done it in modeling is how the cloud of liquid nitrogen spreads on the ground and how far it goes. And we are using some work related to the spread of LNG, liquefied nitrogen gas. But the new project that we are starting, and we think that it will have easy application, and this is the model that we're going to use, is for tanks, for storage tanks, to supply the liquid nitrogen, the fixed system. So we, as you can see, we want to supply the liquid nitrogen, okay, through the center of the tank, near the surface, and it will be a fixed tank there of liquid nitrogen. When, if there is a fire, the detection, this pipe will be insulated, and liquid nitrogen will go near the surface of the cool fire, of the tank, of the top of the tank, and it will extinguish the fire efficiently. So this is the new project we're working, again, with not much funding, but we expect to have an application for a patent. So with this one, I think that I can motivate some people to work in this area, and especially for a specific application. And I think we are working also on this with SP, Dr. Preston, on this last item. Thank you very much for your interest.